Hello everyone, welcome back. This is Elvi Prasad. As per the topic, how to integrate UI test framework and execute in Selenium Docker containers, we already discussed about basic introduction to Docker and installing the Docker in Windows OS and what kind of a configuration we have to select for the installation, which we already discussed in our previous discussions, right? So let's get into the today's objective of the discussion is about integrating the suite automation suite with the Docker Selenium Hub. As per this topic, we will cover the difference between the traditional Selenium Hub and the Docker Selenium Hub. And as part of this Docker Selenium Hub, we will be using few images related to the Docker Selenium. So a basic introduction to each image of it, how it will help and what it contains, how do we integrate and all that. And finally, yeah, so executing the scripts in the integrated Docker the containers. So let's start with the difference between the traditional Selenium and Docker Selenium Hub. So when I say traditional Selenium, so we already have this setup which where we'll be installing the hub and registering the nodes in local machine or any of the virtual machine, right? So this is a Selenium Hub, and this one is a Chrome as node, and this one would be another node which is Firefox as node. So we we used to integrate using the command line previously to register these nodes with the hub, right? So then the connectivity, the integration between the hub and the nodes gets established, and also the Selenium Hub receives the request from the automation suite, right? Which is about so Selenium Hub. This is automation suite, right? So this is our current we can say previous design where the automation suite interacts sends the request to the Selenium Hub through remote WebDriver, and Hub will communicate with the register nodes and executes our test cases in that, right? So what is new in this with the Docker? So what Selenium had done is Selenium had created a wrapper on top of the existing components. So this is a wrapper on top of Selenium Hub, and Selenium named it as a Selenium Hub image. So when Selenium created a wrapper to make it work in the containers, what Selenium did is Selenium created a wrapper by returning the Selenium Hub functionality. Okay, what is that hub functionality? We will discuss it in the next in a few minutes. So Selenium also provided the wrapper for the Chrome, even in fact for the Firefox as well. Along with these two nodes, so Selenium also provided image for the Opera browser, and the image name for this is, I think it is Selenium node Chrome, and for this is Selenium node Firefox. Okay, so these are the image names. Let me put it as an image and image, right? So these are the image names provided by Selenium, and all these images will be available inside a, it's not available, we will be downloading, that means we will be pulling these images inside our Docker server. So we pull the images means it's a kind of a, if it is a Maven project, we download the dependencies, right? Similarly, in Docker, we have to pull the images from the repository into the Docker server. So what is this Docker server and all we discussed in our previous session. So and the communication between the automation suite to the Selenium Hub remains same. Just there's a slight change. So previously, when we don't have this Docker in the traditional world, automation and Selenium Hub automation suite communicates with the Selenium Hub using the Hub URL, right? Even with the Dockerization also, that means containerization also, this automation suite will communicate to the Hub URL with a little slight modification that we will see. Okay, so this is the overall difference between the orange one, which is a traditional, Selenium Hub and the node integration, and the the green one are the Docker stuff, which are available with the as in images to work in the containers. So let's get into the second one, which is a basic introduction to each image. Okay, so when I say each image, so these are the images which we will be using in today's discussion. And let's get into the Docker Selenium documentation to understand each image. So login into the login into the Docker Hub. This is Docker Hub, not Selenium Hub. Mm, Docker Hub, yeah. So this is the Docker Hub. Login into Docker Hub and search for. If you don't have account, just create it. It's a very simple, straightforward steps. It doesn't take much time. So login into the Docker Hub and search for the Selenium or Selenium/Hub, which will give you this result. This is the image name, and this is provided by Selenium. So open this image. So this will have the documentation. So this is the README. This is the GitHub, which is already opened here. So this is the source code available in the Git provided by Selenium. This source code is about the hub source code. I mean, creating the images for the hub, creating images for the Chrome node, Firefox node, Opera node. For all that, this is the source code. And below is the these are the list of images which are provided by Selenium. So it is Docker images for Selenium standalone server, and also for the hub, and also for the node configurations. The node configurations are like Chrome, Firefox, and Opera browser, right? So these are the list of images. So what are the images which we will be using as we discussed here is Selenium Hub image, Node Chrome image, Node Firefox image. So let's start with the Selenium Hub image. So this is a Selenium Hub image, you know. So what is the functionality of a Selenium Hub irrespective of traditional Selenium Hub or the Docker Selenium Hub? See, as we discussed, the difference is only Selenium created a wrapper on top of the traditional Selenium Hub and make it and created an image so that it will be executed in the containers. So that is the difference, right? And Selenium, when Selenium created the image, it retained all the Selenium Hub functionality, right? So what is that Hub functionality? So hub is having the grid. This is called as a grid. It is having the functionality as a grid where grid hub. So that means hub means it is a center which will receive the request from source. In our case, the source is automation suite. Source in one of the way in our example, the one of the way is remote WebDriver. So hub is having a functionality to receive the request from the remote WebDriver, and hub is also having the functionality to receive that request and also send that request to the its child nodes, which are nothing but these nodes, Chrome and the Firefox nodes, right? So that is the hub functionalities. So this is the image available for that. And what are the other images which we have to discuss is a Selenium node Chrome image, Selenium node Firefox image. Okay, so this is the Selenium node Chrome image. Okay, and we also have for Chrome browser only, we also have Selenium node Chrome debug image. So what is the difference? Let's find out. So what this image is contains is here it is given. So this node Chrome image is having a functionality of grid node. That means it will act as a grid. The functionality of a grid is to receive the request from the hub and perform an action based on the request received on the browser. The browser, this is a Chrome image, right? So obviously this will have the Chrome installed in it. So this is the, see, it also says that Chrome installed. So the grid is having a functionality to receive the request from the hub and perform the action on the browser which is available installed in this image. and the grid is the grid also having a functionality needs to connect it to the grid hub. So grid alone it can't act, it cannot do anything, right? It has to, it needs to have a source where it will receive the request, right? So that is the reason this Chrome image is having a grid functionality which will receive the request. How it will receive the request? By, by connecting it to the grid hub. Once it connects to the grid hub, it will receive the request and perform the actions on the installed browser, which is Chrome. So to give more info on this, so does this image is created on top of Chrome image? Yes. So Chrome Selenium doesn't develop the Chrome image. So as we know, so even today, if you take any of our automation suite like a Maven automation, if you have to, use any web driver of a browser driver, like a Chrome driver or a Firefox driver, what we do, we directly go into the Selenium downloads and we find that driver and download it, right? So that Selenium site will give you the path where you can download the driver. That means Selenium will point you to the driver provider. So this is a Chrome product of a Google, right? So Selenium points you to the Google site where you can download the Chrome driver. Similarly, now for the Docker containerization, so for this image, for the Node Chrome image, what Selenium did is Selenium picked the Chrome image from the Google site and it created a wrapper on top of the Chrome image by enabling the, by providing the grid functionality, which can receive the request and perform the actions on the Chrome by registering it to the grid hub. So this is the functionality and the behavior of the Node Chrome image. So it is the same for the this one, the Node Firefox. Okay, this is a Firefox image which is created by Selenium by creating a wrapper on top of Firefox image. Firefox image is provided by Mozilla. By taking that image from Mozilla, Firefox image by taking the Firefox image from Mozilla, Selenium created a wrapper on top of this by enabling the grid functionality, which will receive the request from the hub only after connecting to the grid hub. The connecting is nothing but integrating with the hub. So this is the functionality of the Node Firefox image. But along with these two images, what we also have is these two images. See, which are sound similar, right? Node Chrome, hyphen debug we have extra. So how this debug image is different with the Node Chrome image is, here it is. So this image is having grid node functionality, which is similar to Node Chrome with Chrome installed. This is also similar to the Node Chrome. Even in this Node Chrome image also Chrome is installed and runs a VNC server. So this is new, right? This functionality, this VNC server is only available in the debug Chrome image, which is not available in the Node Chrome image, right? And needs to be connected to the grid, so grid hub. So this is also same with the Node Chrome, needs to connect it to the grid hub. So what is the special difference is VNC server. So this image, so this Selenium Node Chrome debug image, what it is having is it is having a node functionality, it is having the Chrome installed, it is having a VNC server, and it is having a capability to register with the grid hub. So what does VNC server? So we know that VNC is used, the definition of the like VNC is used to communicate with the remote missions, right? By using the SSH key and all that, right? So virtual network computing, it will help us to connect to that server remotely. So that is the functionality of the remote server. And the beauty of this image is by default this image is having this server. Okay, similarly for the the Firefox as well. Firefox debug and the Firefox node, the difference is grid node, both are same. Grid node, Firefox installed, both are same. and runs a VNC server. Here we don't have that VNC server here. Needs to be connected to the grid hub. So here also it is needs to connect it to the grid hub. So by having the VNC server, we can connect to that node and witness what is getting executed. So 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 this is the difference between these four images. That means node Chrome and node Chrome debug. So then we will take this image only so that we can log in into this node and witness what is getting executed and all that. Okay, so let's start with the pulling the images. So what is the third one? Execute the script set. To execute that, we have to pull all the images and integrate, right? So let's start. So see, the command for that is here, it is available. So how do we pull the image? So this is the command. Copy that, paste it here. So Docker pull Selenium Hub. So in the previous discussion, we talked about the couple of commands, right? Pull, run, and the build, right? So, and along with those commands, we also discussed about push and tag commands, right? So, and we also discussed about how the tagging is done in the Dockerization, right? So, any production image will have a tag called latest. I'm not sure why it is not getting downloaded. Let's cancel this thing. I'll launch a new PowerShell. Okay, 1 second. I'll just. Today the network is very slow. Maybe for that reason it is taking time. Okay, I'll clear it. I'll put the same command here. So in the previous discussion, we also discussed about the tagging, right? How the version is getting tagged with the image and what the version will have for the production images, right? So let it start download. Meanwhile, I will pause the video due to the network delay. It is taking time. Oh no, it started. Okay. Because see, it is saying is using default tag called latest. Latest means it's a production image. So for the any production images, it won't have a version number. Instead, it will have a text called latest. Latest means it's a production image. So it is pulling that image from the repository called Docker Hub. It will take some time for the first time to download. So meanwhile, I will pause the video. So right, so it is started pulling the images. What it will do as per this, the download process, that means as per this pull process, what it does is first it will download the image, then it will extract the image, then it will, install the image. So once everything is done, it does the each and every step very fast, so that it's very hard to find the statuses of everything. So once everything is done, then it will say pull complete. So this image is having all these binaries. So all these binaries it is downloading and extracting and pulling. So once everything is done, the status will show as pull complete, and finally we should get a text here as the pull is success. So let's wait for that. So waiting for the lost email, lost binary. Yeah, sometimes it takes time if the binary is the size, the large in size. Right, so once the image pull completes all the binaries, then the status will show as pull complete, and also you get a status download newer image of a Selenium Hub. The latest is the version of it, which is success. It didn't give any other, right? So that means it is success. So the next image what we discussed is Chrome debug, right? Let me copy this one. So Docker pull Chrome Selenium node Chrome debug, right? Let's pull it. It's also same. It will start using the default tag as latest. then it will start all the binaries available under this node. It will have more binaries because this is having VNC server, and also it is having the Chrome installed, right? So this will contain a more binaries. We will see that. So till then I will pause the video. Right, so as we discussed, the node Chrome debug is a binary which will having the VNC server, Chrome images, and right. So that is the reason it is having so many binaries available. So when it installs, it will check what are the binaries already available in our local Docker server. Local Docker server. If it is already there, then it says already exists. If it is not there, then it will pull it and install it. So here initially when we tried the Docker daemon. So daemon is a service which we spoke in our last discussion, right? Daemon is a service which helps to communicate between the Docker client and Docker server. Due to the network delay, I guess it didn't the request got timed out. So I tried again. So in the second attempt, it is the connection to the Docker Hub is success, and it is downloading the image along with the binaries of it. So let's wait till it completes everything. So this binary is of this much of a size, MBs and KBs it is. So it will download everything. Let's wait. Right. So even this node, Selenium node Chrome debug image also got pulled to local Docker server. So let's pull the second image, that is Firefox image, right? Okay, again we'll pause it. Right, so even the latest image, which is a Selenium node Firefox, even this also pulled successfully. So as we see the status, download newer image of a Selenium node Firefox. This image and the latest and the tag, I mean that means the version of that image is latest. That means it's a production image. It is downloaded from the Docker means Docker Hub. Okay, so now we pulled all the images which are required for our discussion. So let's see the Docker info, what it shows. Okay, so as these images are installed into my local Docker server, so we should see the image count here. So please bear with me for the delay. Seems to be my system is slow today. Right, so this is the result I got when I did the Docker info. So what it shows is this Docker server is containing 0 containers, the containers with a different state which are running 0, passed 0, stopped 0. So that means totally 0 containers. So now we install two images, right? Sorry, three images, right? All these three images. So that is the reason image count is showing as 3. So let's find out what these images I mean how these images looks in the Docker. So let me clear it out. Docker. So to find the images, the command is images, Docker images. So this command will list all the images which got downloaded, from where it is downloaded, the created date, and all different information. So this is the image name, and the version name for that is latest. This got an image ID. So every image and every container will have an ID associated to it. Okay, on this image ID, and it got created 6 days ago. That means 6 days ago means it is not in my local server. This is not this is not referencing my local, because locally we just downloaded, but 6 days means 1 week back, right? That means this image got pushed to Git repository. That means I mean to say a Docker Hub 6 days back. So this date, created date, will refer to the Docker Hub, image push reference. So now we have the Docker, sorry, images. So let's create containers. So how do we create the containers as we discussed in our previous discussion? That is, a container gets created when we run any image. So if we run these images, a created gets created. So how do we run this image? Can we directly run and the image name here? This will work, but this will not help me. That means, hey, if we do this, a hub will get started, but how it will help me? Because see, the functionality of a Docker is any application or any image which you download or any image which you run in a container, that application accessibility will be specific to the Docker itself. You cannot access that application outside of the Docker. That is a restriction of Docker. To make that is to make that application accessible out of Docker means you need to publish the port. When once you publish that port outside, so the I mean so for example, you if you take the CI/CD open source Jenkins uses a Jenkins default port is 8080, right? Similarly, our Selenium Hub default port is 4444, right? So that Selenium 4444 port, we have to map it with our local mission. Local mission means the mission where you install the Docker. It could be your local mission or it could be a virtual box where you install the Docker. So you have to map the Selenium 4444 port with your local mission port. Then only Docker, that means what we are telling to the Docker is I'm exposing the Docker port 4444 to the Selenium port. So how do we do that? So the syntax for that is hyphen D hyphen P. So what is hyphen D hyphen P? Let's get into the help. This will give the all the information about the Docker run. Come on. Right. So the Docker run is having all these internal commands. So what we will be using now is hyphen D. That means detach. D means detach. What it will detach? So when you say Docker run D, that means run container in background and print container ID. So when we execute a Docker run with a D, so this does in the background. And also we shall be using the hyphen P also. Hyphen P means hyphen hyphen P hyphen P hyphen P. Right. So what the hyphen P is, this is the capital P, this is a small p, so there's a difference. So we will be using the capital P to publish all expose reports to random ports. The host, so a small p means publish a container port to the host. So but it is saying publish a container port to the host. Host means local machine. It could be a local machine or it could be a virtual machine, but in host which port it is. It is not clear about that, right? So we will use the capital P so that publish all exposed ports to random ports. Okay. Right. So okay, so let's get into the command docker run hyphen D for detach and hyphen capital P, which we said, right? And we have to use link to link it with the the local Selenium Hub which is available to hub, and the what is that? The current image name is Chrome debug. Okay, so let's check is this the correct one? Correct one in the documentation. Standalone Chrome. Here they use grid and hub host and all, but that is fine. We can use V means volume. The where is the volume is the data where it will store all the logs and all, but that's fine. We'll go with the this normal thing. I think I saved it my GitHub repo where we are saying is with hub, and yeah. So so here it is Docker run. detach and publish the port to the local host, random ports, local host random ports. That's what it is, right? Publish all exposed ports to the random ports of local host. And we are tagging and we are linking that with a local hub server from the hub, and this is the node which is getting created. Before that, let me execute this grid console. Right. So we see till now we we discussed only registering the hub, right? But and we exposed that hub using the port 44, right? So that is the reason we are able to access the grid console here using the port. Okay. Now we are registering the node of a Chrome. So that is the reason there is no node available at unless we register to this. Okay. And also let me pull another PowerShell to show what are the containers which are running. Okay. So here I will try to list the ports docker ps. This is the command which will list all the current running ports. So as we already in our previous command, what we done is the we docker run Selenium Hub we used, right? So that is the reason docker run, and we used Selenium Hub image. So docker run command will run the image by creating a container, and it creates a container ID for that. So right now we ran only Selenium Hub image with docker run. So that is the reason it having only one container. The moment if we run this node Chrome debug with using the docker run, what we get is so what we get is another container running for the node Chrome debug. So let me run this using the capital P. That is very much important because when once the port is published to the local host, we can log in into that node and see how the execution is happening. That is the difference, right? See what this debug image will have. What is the difference between node Chrome and node Chrome debug image? There's a difference, right? Slight difference is this one. Right. See, Node Chrome doesn't have a VNC, but Node Chrome debug is having a VNC where we can connect to the remote machine. So that is the reason we are giving a -p so that the port gets exposed to the local and we can connect to that remote machine. So now the registration for the registration of a node Chrome node to the hub is done, right? So if you refresh, you should see a node here, which is the Chrome is available. Now the now same thing repeat command for the Firefox. It's not the same command. In fact, it's a Firefox node, but the rest remains same. That means I'm running detach means it creates a container and publishes the container ID, and it publishes the port, and I'm linking this node with a local Selenium hub, which is nothing but the Docker hub, the available Docker hub. So let's run this. It should give a digest ID. So yeah, we got the digest ID. And if you run this command again, you should see total three containers. One is for the hub, one is for the Chrome, one is for the Firefox. So let's expand this. I'll show you. Okay, so expand this. Right. So one is for the hub container, node Chrome container, node Firefox container, which is in debug. And you also see this here, right? See the ports. See, we got the ports exposed here. So using these ports, we can log in into the, respect to, respect to nodes to see how the execution is happening. Okay. And yeah, in the grid console also, we should see Firefox. Yeah. So we got the Firefox also, right? Right. So this completes the traditional of understanding the difference between Docker and the traditional of Selenium Hub, and the basic understanding of all the images. And we pulled the images, we integrated the node and Selenium Hub. Now the pending part is executing the scripts in the Docker containers. Okay. So for that, what I did is I created a the lightweight framework here. I'll just give me a minute. I'll remove this. Okay. And yeah. Okay. Okay, so what I did is I created a lightweight framework here, which is having a source test one source which is of a test, and in that I created three packages where the pages, step definitions and utilities. Pages is nothing but our I'm using the page object design pattern using the page factory initialization. So under the pages, this package, I will be creating all the all the Java classes with respect to capturing the page objects and writing the implementation of that objects. And I have the step definition where I will be writing all the what are the step sequence of the scenario inside the step definition. And I have the utility class where I will be using the global page factory initialization. How to do this global factory global page factory initialization, I had covered it in one of the video. Please check it once if you still have any doubt. And I have the hooks class here where I will be handling the before and after. Hooks before will take care of launching the browser, and after will take care of closing the browser by taking the screenshot if it is failed. Reusable actions, it is having the the launch of the driver and the close of the browser. And the test runner is something which will have the glue code, right? And inside this test runner, and I'm using the at after class JUnit annotation here. And inside this I'm using the extent extent report configuration where it will create an HTML report which is provided by Vimal Selvam. This is a wrapper on top of extent report, which is for this you don't have to follow like creating the extent report at the start of at the start of your automation framework execution and keep on adding the steps whenever required, and at the end flush it and all. You don't need to do that. So what Vimal Selvam has provided is he created a wrapper on top of extent report, which just reads the JSON of the Cucumber and creates HTML format. Similarly, there are a few more wrappers created by other people, but I get used to use this Vimal Selvam's dependency. And yeah, for extent report we have to use this extent config, right? And the login feature, I have this one scenario where the and for this what I'm using is a Mercury interactive tools site. Where is it? This one. So this is a Mercury Interactive. If you remember, the Mercury Interactive is the company which provided the HP QTP, HP load runner, and all that. Later, the Mercury products got acquired by HP, and now it got acquired by Micro Focus. So I'm using their site where so I will launch the site from the home page. I will navigate to this link and I fill few fields here. So this is the functionality which I will be showing in the demo. And for that, I created a scenario where I will be checking I am in that page. Then I will enter these fields and I will click on the submit button. And I am using the data driven and I will passing the test data within from the scenario examples itself. Just I copy pasted the same scenario two more times. Just execute it three times. Okay. So this is a very lightweight framework. Before the now we have this containers running. We can integrate the our automation suite. So what is pending is we can integrate our automation suite to the Selenium Hub to the same port which was exposed and execute it. But before that, before the integrating to the automation suite, I would like to show it to the normal way of execution and how it works in a normal way. So okay, so let's go navigate to the directory where it is available. It is available in this C. It is available in the C users, my account, desktop, and in a directory called e-learning. And it is yes, this is the one. Okay, so what I say is mv and clean. So what clean does it? Okay, e-learning. Yeah. So there is a target folder. That means it's from the previous execution. So what clean does is it cleans everything from of the project so that the unwanteds will be removed. Unwanted files, not the imports. It is taking some time. Maybe let me pause it for some time. It is taking time. I don't know why. I will cancel this one. Cancel this command. I'll execute it from here only. So I'll directly execute the clean install so that the execution gets triggered. So I created a Maven goal here with the clean install. So when I run that, it started. First it will clean, then it will install, then it will start with the execution as per the goal. Okay, deleted. Now it is compiling the project. It compiled. Now it is triggering the plugins, then started with the tests. Okay, the glue code got triggered from the test runner. The Chrome browser found. So as I said, I have three scenarios of the same functionality. So this should open, the browser should launch and navigate for 3 times. One time over, second time, and yeah, second time, then third time. Right. So this is about the functionality of that, and the summary it should print, right? So the build is success, right? This is the normal way of executing without Docker in picture. So now let's integrate the Docker. So to integrate the Docker, what we have to do is we have to use the WebDriver manager, right? So for that, I will be commenting this normal way of initializing the WebDriver, and I will. Okay, let me copy this desired capabilities. I have it in my thing. Okay, and desired capabilities Chrome and this thing and driver and URL. Okay, this is desired capabilities. Yes, yes, and correct. No cap set capability. Change to set capability. And this is the remote web driver, Selenium remote, yes. And this is the capital URL for the this thing. Okay, right. So now execute. So now what we did is okay URL, right? After this, we have to navigate it to the URL. Done, no? So now when we execute, what it does is the driver gets initialized with null here, and the desired capabilities get initialized before, because this I am calling from the at before the notation hook. So desired capability will get triggered and the remote WebDriver gets triggered, and this is the port which was exposed at the time of hub registration, right? So the same port we are using with the hub extension here, the hub as the endpoint, and the driver URL is this. So let's execute and see how it works. So now we are integrated with the hub, right? So the execution will take inside the hub, and the hub is available inside the Docker server, right? So we cannot witness the execution normally, but I will show you how to witness the execution, ongoing execution. So now the Chrome browser found. It will launch the browser now. It's happening inside Docker. So it completed with one scenario. It started with the second scenario. So even second scenario is done, and this is third scenario. Even this is also done, and the summary is getting printed as success. So total three scenarios, of each scenario is containing three steps of a nine steps. Totally it completed executing inside Docker. So when we execute this, how can we see that while execution? So for that, what we have, so as I said, we registered this nodes with -p, right? Yeah, so with hyphen capital P. So when we register the node with hyphen capital P, as per the Docker run help, what we have seen there, it will run the image in a container. It will create a container and it will run this image inside that container by detaching. Detaching means it will create a container ID and it will publish the port to the local host, to the available hosts in local. So this is the available port in my local. Right now the browser what we use is Chrome, right? So for this Chrome, what is the port is 5900. Okay. So I have this VNC server. Okay. So which I say localhost. Sorry, not 590. The localhost 32769, right? This is the port. This is the port which you have to use. Localhost 32769. 2769. Okay, connect to this. Yeah, it is connecting. Yes, connect. It is asking a password. The password is available in this Selenium Hub as a secret. Right. So when you prompted for the password is secret. Okay. Right. So now we are connected to the node of a Chrome. Okay. So now we connected to this node, which is a Chrome. Now let's trigger our execution and see how it is executing. So previously we are not able to see the execution when it is executing inside Docker, right? Now as we connected to the VNC server available inside that this image, the debug image, now we should be able to see the execution live. So it started. Once it starts the tests, we should be able to see the execution here. So it started this tests. Now the Chrome browser should launch. Yeah, see it launched. So this execution is happening inside the container of that image. Previously we couldn't able to see because we didn't log into the node. Now we logged into the node, so we are able to witness the execution. Okay, so this is the third scenario, right? Done. So all the scenarios these got executed with each scenario is having 9 steps. Sorry, 3 steps, which are of 9 steps. Totally done. So how many ways we executed this without the before integrating the automation suite to the Docker, we executed normally. So the browser launched within local machine and executed all the scenarios. Then we integrated the automation suite with the Docker Hub using the remote web driver. Then we triggered the execution. Then what happened? The execution executed inside the container, which we are not able to see. But on the third attempt, when what we did is we executed inside the Chrome node, and we connected to the node using this port using the VNC server, which is already which is already installed in this image as per the documentation provided by Selenium. Uh, what is that? So as per this image, the VNC server is already installed in it, right? So that is the reason we are using VNC server and using the port which was exposed when we use hyphen capital P. The port got created, and by using the same port, we logged into this, this VNC. And you can connect in two different ways. Like one is this, local host, and the one is the same thing what is displayed there, like 0.0.0.0 and connect. This will also connect. Not valid. Okay, then you can use the local host and the port number. Then it will connect to the node, and you can witness the ongoing execution of it. So this is about the total discussion about the integrating our automation suite with the Selenium Docker Hub and executing that even in the Selenium Docker Hub. But with this, the drawback is so in tomorrow. So now you have the three scenarios. and maybe you might have 10 scenarios or 20 scenarios. But later, if you want to create a new node, you have to pull that image and register that image, like this. You have to register that image to the hub, right? This is a manual process, right? So there is no auto scaling available in the Docker Selenium Hub, but there is another wrapper on top of Docker which provides a auto scaling. That means what happens here, the grid is based on your test count, based on your text count, the test execution count, that means test cases count. The Docker is flexible to increase the nodes here, and if your test count is less, it will decrease the nodes here. By default, that Docker wrapper is called as Selenium. It called as Selenium. This is the one. So this is the topic which I will be discussing in the upcoming video. So so this is about the current discussion is about the integrating the automation suite with the traditional the Docker Selenium Hub. Thanks for watching. Thanks for your time. Thank you.